mollifies and reduces, it's called the maritime effect. It reduces temperature swings. Everything we could do to make extremes come down and be in a tolerable range is going to be beneficial to life. And water is great at that. It's really hard to heat the ocean. It's really hard to cool it. It's a very stubborn ocean. Did you notice that the summer in our calendar, in our culture, starts on what day? It starts on the hottest day in the sense of the highest forcing. It starts on the hottest day. And then we say June and July are the hottest days. We get pretty hot here, well after the peak of the sun in the northern hemisphere. So we have the peak sun beating down on us when people are getting married, and the weather's June, and it's gorgeous. Because we have this huge lag, almost 2 or 3 month lag, between the forcing that's going to force summer to happen and the summer that happens. There's a huge lag, and it's caused by water's heat capacity. Mars does not have that, and when I showed you summer on Mars and winter on Mars, I was not delaying it by 3 months. I was showing what we would call the start of summer, and that was the dead middle of summer. Because Mars reacts not in months, it reacts in hours, like a laser. That's why when I showed you the Mach number, you could see the day-night burned into the Mach number because it just happens within hours. The sun beats down like a laser, and it's hot right now. And it comes away, it's nighttime, and it's cold right now. And there's no lag. And so the seasons are instantaneous on Mars, very, very different than Earth. But on Earth, you get this incredible buffer because we have these huge oceans. The fourth one is water. This is a technical one having to do with the biology as we understand it. Water actually is bioactive. Any biologists in the room? Water is actually bioactive. It actually takes the enzymes, which are these proteins that help catalyze reactions and have, for example, us be able to live at very low temperatures. We are little fires walking around, but we're not hot like a fire. We are burning oxygen, just like you would with a fire, but we're not hot like a fire. We can't even touch a fire. It's too hot for us. How does that work? Well, the biology is very clever. It can actually burn at a very low temperature. That's one of the most clever things that biology does. Okay, but to get that to work, to get those enzymes to lock together, you've got to have water, and water actually in 3 dimensions actually torques and bends the enzymes like little Legos and sticks them together. You take away water's ability, water's an asymmetric molecule. You take that bioactivity that water comes, and that solvent is not just a solvent, it's actually a bioactive solvent. So, oh my gosh. So all 4 of those things. I think water is one of the most amazing molecules in the whole, and it's also one of the most common in the whole universe. Okay, so it's got to be liquid because it has to be solvent, and water is the most reliable solvent. And so if you find liquid water, if NASA has been charged now for years to basically find life somewhere else. And you talk about follow the money, follow the water. So the Mars mantra, the mantra for NASA, all through the solar system, other extrasolar planets, is to find water, find liquid water, find places that could have liquid water. We call those the habitable zones in extrasolar planets. And so liquid water on Mars today, that's what the title of this talk is. This was 2011, 4 years ago. This was not incorporated in the Martian movie because he didn't know about this. The book came out at the same time this came out. Images from the high-resolution imaging science experiment, HiRISE camera on the Mars Spy
Here is
Telescope.
rotating the globe of Mars, and we're going to zoom in on the middle southern latitudes, the part of Mars where we find these active slope features, and we're zooming in on the Newton Basin crater here. And what you can see are lots of gullies. The active features that we recently discovered are on the slopes that are facing mostly to the north, to the equator. What we see are much smaller scale features than gullies. You can see an area of bedrock, a steep cliff here, and it's from that bedrock that these dark features flow out. Given the latitude and the slope aspect, in particular the temperatures, it suggests that there is a volatile involved here, and the appropriate volatile for this temperature is water. Probably salty water, because sometimes these are active when it's a little bit below the freezing point of pure water. Salt lowers the melting point. And water on Mars should be salty. We know there's lots of salts on Mars. This is potentially actual water in the liquid state flowing on Mars today, not millions of years ago. And then late spring and into the summer is when these features form and fade. By late summer, early fall, they'll be completely gone, and we'll see just a normal looking slope throughout the winter. every place where we have multiple years, these features recur. They're not exactly the same. They may be more or less active one year than another, but they keep coming back.
So why did NASA sit on this if it was that amazing? That's the game changer. Actual liquid water today. And it was discovered in 2011, the same year that the book came out. So Mark Watney doesn't get to get liquid water like he could have. So in 2015, which is just, frankly, a few weeks ago, about 2 months ago, NASA came out at the same time as The Martian, the movie, came out with a big press conference. What is it they're going to say? Well, the press conference was that they had confirmed spectroscopically from these remote spy telescopes that those damp patterns that keep recurring in the equator, so you gotta go through all the things that make it hot, right? The equator, the summertime, the sun-facing slope, so everything's hot, because Mars is a very cold planet. You get all this dripping damp stuff running down. And you notice how cautious Al McEwen was. He was possibly water, likely water. They knew it was water, they knew it. I mean, but they didn't announce it. They're extremely cautious, because they know if they announce it and it turns out to be false, that would just be horrible. So, yeah, so they're very careful. And what happened this year to make the change? They did the spectroscopy and they got hydrated salts. Can only form in the presence of liquid water where the damp features are. And they moved the spectroscopic, the little footprint of the camera over just to the side where the damp features do not appear, and they didn't get hydrated salts. The hydrated salts are happening where the damp features are happening. And that was more than enough. They said, oh, good grief. They called the press conference. We have the smoking gun. This is water. This is liquid water now, and it's forming hydrated salts. By the way, the hydrated salts are perchlorate of magnesium. You guys know it as milk of magnesia. That's what they saw, is the spectroscopic signal of milk of magnesia and some of the other things really that are very dilute, but very clear, has to be in the presence of liquid water today, right now. So that's the exciting thing. That's the game changer, and that's affecting all of the planning, both at NASA and the European Space Agency. We got liquid water. We know where it is. We go there and look. And it's probably not just where you see it. It's probably just a little bit under. You probably have it. I mean, that's just where it's most exposed, but you probably can find it some other places, just like you could on Earth, just like all over the place. Just go to Bowling Green. Okay, so Mars has liquid water on its surface right now. That's the big punchline for today's talk. Now let's just end with a couple of ideas about Mars tomorrow. Obviously, we want to go there. Why? These robots are doing great, right? They are doing really well. And they're doing better each time we send a new one. They're more sophisticated, they're bigger, they're more ambitious. But they are so slow. Have you noticed? 11 kilometers. They've been on Mars for 3 years. Curiosity had gone 11 kilometers. I have to go farther than that to get home tonight. It turns out if you had an astrobiologist and a geologist on the surface of Mars, they could do in 1 day what it takes a rover about 2 months to do. And so that's one of the reasons. It's just efficiency, and also they can react very quickly to the discoveries. And so there are lots of scientific reasons, more so than, say, on the moon. There's lots of scientific reasons to put an astrobiologist and a geologist and maybe a couple others on the surface very fast, much faster than a rover. So in addition to that, we do have an atmosphere, so there are some ways that you can explore more of, and you can hop from one side to another. There is enough of an atmosphere to have balloons, hot air balloons will work, and also there's some drones designs, really interesting. But of course, let me end with what brought us all here today, I think, which is this idea that we could actually grow ourselves. And if we get abandoned, we could grow potatoes. All right, well, thank you so much for coming.